Last semester, TCD engineering students were given a project to program a buggy traffic system, the end goal of which was to have 3 buggies moving in tandem around a track, following certain rules. We were to use Arduino microcontrollers attached to buggy motors, as well as a central controller running on C#. Here's how our group did it. This is how the track looks before we begin, with the green box representing the buggy and the red blocks the gantries. The first thing the buggy does when it is turned on is calibrate. It does this with 2 IR sensors mounted on its bottom. These sweep under the buggy and obtain the maximum and minimum values for the blackness observed. These can then be used to determine whether the buggy is on the line or not. The buggy then sends a signal to the controlling computer, saying it wants to register. The computer checks how many buggies there already are and sends a signal back, giving the buggy an ID. It is now registered. Based on this ID, the buggy gives itself a bay to park in. It also sets a bay's left counter to 3, so it can drive past the parking bays in front of it, rather than attempting to turn on them. The computer then sends the buggy a signal telling it to go. At each bay, bay's left decreases, and the buggy follows the line, turning when it reaches the fork. The buggy then reaches the first gantry. An IR sensor on its roof detects a pulse from an emitter mounted on the gantry. Each gantry has a different length pulse, so the buggy knows which gantry it is under. The buggy then sends a message to the station. The GAN part indicates a gantry message, the B1 that it is from buggy 1, and the G1 that it is under gantry 1. The system then saves that buggy is there, before checking if anything is in the next area. If another buggy was moving towards or waiting at the next gantry, the system would wait until it had moved before telling this one to move. For now, the buggy is simply told to move on. The buggy communicates with the computer via an XB wireless device mounted on it. We pair a second one to this and then connect that to the computer. This allows them to communicate freely without worrying about interference from other nearby devices. When the buggy reaches gantry 2, the same process occurs as at the first. Let's move on to gantry 3. Again, the buggy sends a signal. This time, however, the computer checks the number of laps the buggy should do. If it needs to keep going, then the number of the lap it is on is incremented. If it has completed its laps, we send it the park signal. When the buggy receives this, it changes the direction it goes at a fork and resets the bay's left counter to bring it forward to the bay it should park in. Once it reaches the bay, it sends a debug type message to the system, telling it is parked. These processes can then be applied when 3 buggies are on the track, as long as they register in order. You can see 3 finishing and parking here. We think that our group should win because our system is simple, reliable and modular. We could add more gantries or buggies simply by increasing the number of instances of them created in the C# code. We learned a lot from this project, and we hope that we've explained how it works clearly and thoroughly. We also had some fun too. We're Group A6, and we hope that you can pick us to win.
Group A6, I'm good at banter.